So in the previous video, we learned about what's called slope-intercept form of a line, aka y equals mx plus b. And really the big takeaway is that if you can write the equation of the line in this form, then the coefficient on the linear term, the number out in front of the x, a constant that we typically use the letter m to denote, represents the slope of the line. And the constant term in that equation, the number that's all out by itself, a number that we typically let the letter b represent, is the y-intercept. So if somebody gave you something like y equals 2/3 x minus 4, you could just look at that and immediately know that the slope of this line is 2/3 and that the y-intercept is negative 4. And conversely, if we had the graph and we could look at the graph and tell that the y-intercept is negative 4 and the slope is 2/3, then we could come up with the equation of that line by just plugging into slope-intercept form. And we did lots of stuff with slope-intercept form. I worked through several different examples, but the very last thing that I did is we assumed that we had enough information to figure out the slope of the line and one point on the line. And that could be given as it was in example B here explicitly, or in example A, where we were given two different points on the line and we had to calculate the slope on our own. But either way, we had enough information to figure out the slope of the line and at least one point that is on that line. And when you had all that information, what essentially you could do is plug in the slope, m, and the point, x and y, into this y equals mx plus b and solve that equation for b, the y-intercept. Because once you know b, since you already know m, you know everything that you need for slope-intercept form, and you were done with the problem. And it wasn't super hard to do that, but it was a little bit more work than you needed to do. The purpose of this video is to introduce you to a second form. So in the last video, we learned about slope-intercept form. In this video, we're going to learn about point-slope form. It'll be pretty similar to the previous video. We're just learning a different way to write the equation of a line, which gives us different information about that line. And in fact, this last example that I did in the previous video will be a problem that's perfectly suited for point-slope form. So let me show you how. First, point-slope form, there's an equation. Just like there is for slope-intercept form, that y equals mx plus b, point-slope form has an equation. It's y minus y1 equals m times x minus x1. And if you have a hard time memorizing this, the way I think about it is if you divide both sides of the equation by x minus x1, then on one side of the equation you just have m, and on the other side of the equation you'd have y minus y1 divided by x minus x1. And this is something that might look a lot like the equation for the slope of a line, which we talked about in the previous video. So if you already have this memorized, you can think about just moving this x minus x1 up to the top of the left-hand side of the equation by multiplying, and that produces this thing, point-slope form. I don't know. If that helps you, great. If it doesn't, ignore all of that stuff. The key thing about point-slope form is it involves three constants. So not just an m and a b, but an m, an x1, and a y1. So you want to use point-slope form when you know m, the slope, and x1 and y1, a point on the graph. That's exactly the scenario we were in this example where we were supposed to find the equation of the line that passes through the point 2, 3. So we could call x1, 2 and y1, 3 and has a slope of negative 2/3. That looks a little bit weird. Maybe I'll put the negative down there. So m is equal to negative 2/3. If I want an equation of the line that passes through this point and has this slope, well, probably the easiest way to come up with that equation is just copy my point-slope form and then change the x1, the y1, and the m into 2, 3, and negative 2/3 respectively. So I would have y minus 3 is equal to negative 2/3 times x minus 2. And you're like, okay, then where do you go from here? You don't go anywhere from here. You're done. If you're just looking for an equation of the line that satisfies this criteria, you can finish right here. This is an equation. It's an equation of a line, specifically the line that passes through this point and has this slope. And you might be like, wait a minute, I thought you told me that the equation of the line that passes through this point and has this slope is y equals negative 2/3 x plus 13/3. This looks really different. Yeah, it looks different, but it's the exact same equation. It's just written in a different form. Instead of being written in slope-intercept form, it's written in point-slope form. So instead of being able to look at it and immediately being able to tell what the slope is and what the y-intercept is, you can look at it and immediately tell what the slope is and what one point on the graph of that line is. And while the work that we did to come up with slope-intercept form here wasn't super hard, it did involve a little bit of work, right? I mean, we still had to solve algebraically to figure out what b is and then go back and plug that into our equation. To figure out this equation of the line, we hardly had to do anything at all. You just had to have this kind of formula, this form memorized, and then plug in the appropriate values. So that's kind of nice. But you might be like, yeah, great, but it's easy to get to this form, but what if this isn't the form I want? What if I want slope-intercept form? What if I want it to look like this? Well, then you got options. You could follow the methods of the previous video, or you can use point-slope form to come up with an equation and then just solve that equation so that it gets into slope-intercept form. What I'm saying is take this equation right here and solve it for y. So I got y minus 3 equals negative 2/3 times x minus 2. If I want to get this y all by itself, it might make sense to get rid of these parentheses first. So maybe the first thing I would do is take this negative 2/3 and distribute it through the parentheses. So I'd have negative 2/3 x, and then a negative times a negative gives me a positive. And if you think about this, 2 is 2 over 1. Then when I take negative 2/3 and multiply it by negative 2 over 1, I get positive 4 over 3. On the left side of the equation, I still have y minus 3. Now I can just add 3 to both sides of the equation, and I get y equals negative 2/3 x plus whatever 4/3 plus 3 is equal to. Let's see, 4/3 plus, maybe instead of 3, I'll think about it as a fraction, so 3 over 1. And then I'll be like, oh, but I don't want my fractions to have different denominators, so instead of 3 over 1, I'll rewrite that as 9 over 3. Right? I'll multiply the top and the bottom of this fraction by 3. Now it's a lot easier to add up the 4/3 and the 9/3, which I think is the exact same answer that I had from above. Let's see. There it is. Y equals negative 2/3 x plus 13/3, the same thing we have down here. So what I'm trying to get at here is there's this new form called point-slope form. And it's really handy if you have one point and the slope of the line. And I think for a lot of students, you first learn slope-intercept form and you get comfortable with that. And you're like, yeah, I don't like this new one, this new point-slope form. I want slope-intercept form. And it's like, yeah, I get that, but it's worth learning point-slope form because it's easy enough to go from point-slope form to slope-intercept form. All you got to do is solve to get it into this form. That's basically it. That's really all I wanted to show you. There's this new form that's really useful. When you have a point and the slope, you can get the equation of the line. From there, you could solve to get it into slope-intercept form if you want, but often you don't even have to. If you're just looking for an equation of the line, you can stop right here. And while it's typically only used to go from kind of the graph of the line to the equation, you could use it in reverse. If you were ever lucky enough to start out with an equation in this format right here, you could just look at this equation and kind of analyze it. You could be like, oh yeah, I got the equation of a line, specifically a line whose slope is negative 2/3 and who passes through the point positive 2, positive 3. Be a little bit careful with the negative signs there. 2 more quick examples to kind of hammer this home. Suppose the point that it passed through wasn't 2/3, but maybe, I don't know, 0,5. So I'll keep the slope the same, negative 2/3, just to keep things simple. But the point that it passes through is no longer 2,3, it's 0,5. You're like, yeah, I guess I could do the exact same thing. I could start with point-slope form, y minus y1 equals m times x minus x1, and then just plug in. Let's see, from the information given, I know that m is equal to negative 2/3, and x1 is equal to 0, and y1 is equal to 5. But look what happens when you plug in all those different values. I would get y minus 5 equals negative 2/3 times x minus 0. And you're like, wait, x minus 0, that's weird. Isn't x minus 0 just x? Yep, it sure is. So wouldn't I just have y minus 5 equals negative 2/3 times x? Yeah, you absolutely would. Couldn't I just add 5 to both sides of this equation and get y equals negative 2/3 x plus 5? Sure. Oh, and now all of a sudden I'm in slope-intercept form, and it looks like the y-intercept is 5. Yeah, because the point that I gave you that this thing passes through is the y-intercept. Because the x-coordinate of this point were 0, the y-intercept of 5 shows up on the left-hand side of the equation as a negative 5. So when we add 5 to both sides of the equation, it ends up being the value of b in our slope-intercept form at the end. I don't know, I think that's kind of cool. But really, I guess to answer the question, we were done at this point, or maybe even this point if you really want to explicitly write it in point-slope form. One more comment before I end this video. It's one thing that I want to show you in these series of videos, and I don't really know where it goes, so I called it kind of leftover stuff. I'll have one more video where I talk about parallel and perpendicular lines, but those will take a while. But before I end this video, I just want to talk briefly about the x-intercept. We've talked a lot about the y-intercept, the value of b in y equals mx plus b, this 5 in this case. But we haven't talked a lot about the x-intercept. All the x-intercept is it's kind of the horizontal analog to the y-intercept. So here is my y-axis. So wherever a given line crosses this y-axis is what's called my y-intercept. And similarly, this axis right here, this horizontal axis, is called the x-axis. And where the line crosses that x-axis, well, probably won't surprise you, it's what's called the x-intercept. Because the y-intercept shows up in slope-intercept form, it's kind of useful to know when we're going through and writing equations of all these different lines. The x-intercept doesn't really show up in any of these special forms, so it kind of gets ignored. But sometimes, depending on the use case of modeling these lines, you might want to know what the x-intercept is. And I just want to show you really quickly how you could find the x-intercept if you have any equation of a line. It doesn't have to be in slope-intercept form or in point-slope form. Any linear equation that has an x-intercept is easy enough to solve for. All you have to do is think about this point and think about what its special characteristic is. What am I talking about? The important thing about the x-intercept is it's on the x-axis. And you're like, yeah, obviously. Right, but the x-axis, the way you can kind of think of the x-axis is it's not 3 units up or 5 units down. It's right in the middle, vertically speaking. So any point that's on the x-axis has a height of 0. The y-coordinate is the height. So anytime you're asked to find the x-intercept, really what you're looking for is the x-coordinate when the y-coordinate is 0. And you're like, all right, fine, that's easy enough. Sure, I guess it is easy enough, but it's kind of confusing. Someone asks you for the x-intercept, and what you do is you make the y value equal to 0. That's kind of the opposite of what a lot of people would think. But the reason that makes sense is because the x-intercept is when you cross the x-axis, and the x-axis has a height of 0. So any point on the x-axis has a y value of 0. And so the x-intercept will just be the value of x that makes the left side of this equation the same as the right side of this equation when the value of y is 0. So you just take this equation, 4x equals 2y minus 9, and change all the y's into zeros. 4x equals 2 times 0 minus 9. Yep, that's it. But isn't 2 times 0 just 0? Yep. So I'd have 4x equals 0 minus 9, or just negative 9. Yep, that's it. And then solve for x. Divide both sides of the equation by 4, and you get x equals negative 9/4. If I ever ask you for an x-intercept, you can just tell me what the x-coordinate of it is, but often people like to refer to it as a point. So as a point, you would write it as its x-coordinate is negative 9/4, and its y-coordinate is 0. That's it. Not super related to what we did when we're talking about point-slope form up here, but I didn't have anywhere else to put this stuff, and I knew I wanted to talk about it at some point, so I figured why not throw it at the end of this video. X-intercept, the last thing I had for this video. I'll call this good here.